So let us turn to the next homologous series now. The next homologous series is alkene. The alkenes. When we talk about the alkenes, the word alkenes make us understand that they are unsaturated. They are unsaturated hydrocarbons, unlike the alkenes. And their unsaturation is as a result of the presence of double bonds between their carbon atoms. Double bonds between their carbon atoms. The first member of the alkenes is ethene. They do not have meth. The alkenes do not have meth. Like that is, they do not have a member like methane. They do not have it. Unlike alkenes, whose first member is methane. That is methane. So in alkenes, you do not have a first member as methane, but the first member is ethane. Others are propene, butene, pentene, etc. The name alkenes are derived by replacing ane in alkenes with ene. That is, when we replace the ane in alkenes with ene, we have the alkenes. Their general molecular formula is CnH2n, where n is greater or equal to 2. That is to say, n starts from number 2. There is no number 1 for n. N starts from number 2. So, having seen that, let us take a look at the structural formula of these compounds, beginning from their molecular formula. So, as we can see displayed, ethene is C2H4. There is no methane in this family. The first member is ethene. And then it continues propene, butene, pentene, hexene, heptene, octene, etc. And each member, as you can see, differs from the next by a CH2. So adding CH2 to the first member, you get the next member. Or subtracting CH2 from the next, you get the previous member. So having seen that, let us take a look at their structural and condensed formulae, just as we did in the alkenes. Let us take a look at their structural and molecular formulae. Their structural and molecular formulae. So to do that, we simply have to do as we did. Let us take, okay, the board is clear now. So we have seen that for alkenes, they have CnH2n as their general molecular formula, where n is either 2 or higher than 2. So if that is the case, it means the first member here will be C bracket 2 into H2. Beg your pardon? Let's look at this. So that gives us 2 bracket 2. So this will be C times 2 is C2H, 2 times 2, that's 4. So this is the first member of this family, and it is called ethene. The second member of that family, which is n equals to 3, is C3. Students should not get this confused. Why did we not start from 1? So they may be confused. Don't get it confused. There is no 1. N is not starting from 1 in the case of alkene family. That's just it. N did not start from 1. It is greater than 1. So N is from 2 and above. So the first member is from number 2 and above. So this is going to be C3H6. And this is propene. So we can go on and on and on and on, and we'll be getting the formulae of all the members in this family. So instead of using the calculation now, I can recall that each member differs from the next by a CH2. So if I'm to add, to make it simple and short, if I'm to add CH2 to my propene, it means I am going to get C4H8. And this gives me butene. If I add next, if I'm going to add to my butene, if I'm to add CH2, it's going to give me the next member there. And the next member is C5H10. And this is pentene. So you can see, either I go by this addition or I use the molecular formula, it gives me my molecular formula, and I can guess the name of the homologous member in that family. So having seen that, let us proceed now to looking at the structural formulae and the condensed. Let us look at how do we take on the structural and condensed formulae. The structural and condensed formulae, that's what we're going to be looking at next. Okay. Let's take a look at this. Okay. So we have alkene, we have molecular formula, we have structural formula, and of course condensed formula. So the first member we have said is ethene. And ethene is C2H4. C2H4. Since it is C2H4, what will be the structural formula? There are 2 carbon atoms in ethene, but we recall that ethene is not a saturated compound. It is an unsaturated compound. We have recalled that ethene is an unsaturated compound with double bonds between each carbon atom. So if that is the case, it means the 2 carbon atoms are having double bonds between themselves. Okay, let me make it simpler. I'm just going to take away this, and for better understanding, let us make it this way. So they have double bonds between the carbon atom. So it means if I'm to call this carbon 1 and carbon 2, so it means carbon 1 already have 2 bonds and carbon 2 also have 2 bonds. And what is left? They are looking for 2 bonds each. And I think that is why the hydrogen can go successfully distributed between both of them. So if I place 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, 1 hydrogen down here, now I have my ethene. Now it is worthy to note that you can place your hydrogen anywhere. It must not be up and down. The hydrogen mustn't be up and down. Your hydrogen can be placed anywhere. So let us take a look at this. I can choose to place my hydrogen side and down. Side and down. I can choose to place my hydrogen this way. So wherever you choose to place our hydrogen, it is fine. Either side and down or up and down. Anywhere is fine. So what will be our condensed formula? The condensed formula will be CH2 CH2. That is the condensed formula for ethene. Because carbon 1 is having 2 hydrogens, carbon 2 is also having 2 hydrogens. So we don't need to put the double bond in between them again. That is why it is called condensed. You are like compressing the structural formula. So when we compress the structural formula, we are having a condensed formula. So let's take a look at the second one. The second member in that family is propene. Propene is the second member in the family with the formula. If I'm to add CH2 to C2H4, I'm going to get C3H6. C3H6. And what will be the structural formula? There are 3 carbon atoms. There are 3 carbon atoms. Since there are 3 carbon atoms, I have to fix in their bond. Since I will have to fix in their bond, the question is, how will the bond look like? We have been told that alkenes have double bonds between the carbon atom. That does not mean all carbon atoms in any given alkene compound must have double bonds. No. So the carbon atom, the first and the second carbon atom can take the double bond, or you may say that the double bond should come between this and this. So whichever you so wish to place it, there must be at least one double bond in that structure. At least one double bond. And that is what it is. So we can choose to place our double bond either here, or as we have said, we can choose to place it here. So let's choose to leave our double bond as it is now. It means that if I'm to call this 1, 2, and 3, it means carbon 1 and carbon 2 are having double bonds between them, and carbon 2 and carbon 3 will be having single bond between them. So there must be just one double bond. The double bond must not be more than 1. For now, we will come to a point where we will have compounds where there are 2 or more double bonds or triple bonds. So having seen that, how do we distribute 6 hydrogen atoms among these 3 carbon atoms? To do so, we have to consider that carbon 1 has 2 bonds already. Similarly, carbon 2 has 2 bonds already. But carbon 2 is not only having 2 bonds with carbon 1, it is also having another single bond with carbon 3. So carbon 2 is having 3 bonds, 2 from carbon 1, 1 from carbon 3. While carbon 3 is having just one bond, a single bond, which also binds with carbon 2. Carbon 1 is having 2 bonds, carbon 2 is having 3 bonds, while carbon 3 is having just a single bond. So it means that carbon 2 needs just a single bond, and we can rightly give carbon 2 1 hydrogen. Out of 6, we have given out 1, we are left with 5. Carbon 1 is having 2 bonds already, so it is looking for 2 more bonds because they must all have 4 bonds. So we can give carbon 1 2 hydrogens. Like I said before, the hydrogens must not be up and down. You can also place it side and down or side and up, anyhow you so wish. Now we have given out 3 hydrogens, we are left with 3. Carbon 3 is having single bond, that is only 1 bond, so which means it needs 3 more bonds, and carbon 3 can therefore take the remainder, and this is how it is distributed. So if we are to write the condensed formula for propene, the condensed formula will be CH2, CH, and CH3. This is the condensed formula for propene. Now, it is worthy to note that if I choose to place my double bond between carbon 2 and carbon 3, 1, 2, 3. If I choose to place my double bond between carbon 2 and carbon 3, then reverse will be the case, as I'm going to have 1 single bond here. It means I'm going to be having 1 single bond here, and then carbon 2 will be having its single hydrogen as it was before, because now it is going to have 4 bonds. Carbon 3 will be having 2 hydrogen bonds as it's having 2 already, while carbon 1 will be having 3 hydrogen bonds as it is. So the condensed formula now will become CH3, CH, and CH2. So what I'm trying to establish here, students, is that either of the condensed formula is okay, is acceptable. So if I choose to go by this method A, or you choose to go by this method B, both of them are correct. Both are correct. So we are going to be seeing more examples as we have seen ethene and propene.